Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. There's a formula we use for this, and it is percentage change is equal to the amount that's changed over the original amount, and all of that times 100%. So how much has changed here? Well, we need to do 10,488 take away 10,254, so that would be 234. Divide it by the original, so the original was 10,488 because it's decreased from that amount, and then times by 100%, and so that's going to be 2.23%. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds. And we're going to do that by finding out what 1 euro is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. The difficulty with finding the perimeter of this shape is we do have some of the lengths missing, so we're going to find the lengths that are missing first and then we'll find the perimeter. So the one on the right here is going to be the same as the one on the left, so this is going to be 5.6. Same with the one on the left of the 2.4, so this will be 2.4 here. This length here is going to be slightly more tricky to work out. What we do is we work out the total length across, or the total width across, which is 9.8, and we take away the bits that we know. So we take away these purple lengths at the bottom. So to work out the length of the missing bit, we're going to do 9.8, and we're going to take away the 4.3 plus the 1.2. And then when we do that, we do 9.8, take away those bits, we get 4.3. So this missing bit here is 4.3. So to work out the perimeter, we're going to start at the top left of the shape and add up all the lengths as we go around the shape. So 9.8 plus 5.6 plus 1.2 plus 2.4 plus 4.3 plus 2.4 plus 4.3 plus 5.6. When you add all those up together, you get 35.6. It's a perimeter, which is a distance, so our units are centimetres. So trying to describe the single transformation, it kind of looks like it could be a rotation, and it would be a rotation of 180 degrees. But if it was a rotation, it would be actually this way around. And so it's not a rotation. It looks to me like it's a reflection, which it is. Now we've got to find out where we put our mirror line. And our mirror line for this would be a horizontal line. So if I just guess and I put it down here, notice that B is only one jump away from that, and yet A is 1, 2, 3 jumps away from that. So that's not very good. That's not the halfway point. So we need this to be the halfway between the two shapes, which is going to be here. And the name of that line, well, everywhere along that line, y is equal to -1. So we call it the y equals -1 line. So it's going to be a reflection across line y equals -1. We've got to first of all identify whose graph is whose. So looking at the green one hits the y-axis at 6, and it says here that Taxico charges an initial £6 fee, which would tally that up, and AB Taxi says that its initial charge is 12, which is on our graph there. So AB Taxi is blue and Taxico is green. Now it says which is the cheapest to travel 20 miles. So what we're going to do is go to 20 and draw a line up from 20. You can see that the blue line is actually lower than the green line. Okay, it's cheaper. So the blue line is cheaper, and the blue line is owned by AB Taxi. So we can see that the first 4 of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. So we can quickly draw a line of best fit for here, and it looks something like that. And if our line of best fit is increasing like we have here, then we say the data is positive. If, however, the line of best fit is decreasing and looks like this, we say that it's negative correlation. So positive if it's going up, which this one is, so it's a positive correlation. And if it's going down, then it's a negative correlation. If the data is all over the place, so it looks like something like this, where you've got the points everywhere, we say that's no correlation. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in 2s, so this will be 28. So the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up, so 21%. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now, it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55. And it's going to be 0.55 times the amount of days. Well, it says the amount of days is X. So it's going to be 0.55x. Then it says that there's just a one-off cost of £15. So you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So for this question, what we need to do is factorise 4t plus 6. Now, factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2, and the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. So there's a few different ways of working out this question, but they all involve working out the area of the cross-section. And the cross-section is the part here. So we want to work out the area of this. And what we can do, and this is one of the methods, is we can work out the area of the full rectangle, which will be 28 by 19. I'm going to call this A. And then we can take away the little part that is not there. So the missing part, which is going to be 14 across. We've got to do a bit of maths here to work out how high it is. So we've got 28 in total, 21 we don't want, so that would be 7 high. We're going to call this B. So work out the area of A. It's going to be 28 times 19, which is 532. Work out the area of B, which is going to be 98. And then to work out the area of the cross-section, we're going to do the big rectangle, take away the small one, take away the bit we have missing, and that will leave 434. Now the volume of any prism is area of cross-section, so cross-section area times the length. So our area of cross-section is 434. Our length is basically how 3D the shape is, so it's going to be 10. And so that would be 4,340. So our answer is 4,340 centimetres cubed. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other list as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. And we know for all linear graphs, we can write the equation as y equals mx plus c, with the m being the gradient and the c being the y-intercept. And here we're given a linear graph, so we're going to first of all work out what the gradient and the y-intercept are. So I'm going to start with the gradient, and the gradient, there's a formula of change in y over change in x, and you can write that as the second y-coordinate take away the first y-coordinate over the second x-coordinate take away the first x-coordinate. And so that's going to be second x-coordinate is 132, take away the first x-coordinate, which is 111, and then the second x-coordinate, which is 18, take away the first x-coordinate, which is 15. And when you do that, you get 21 over 3, which is 7. So we can rewrite our equation now because we know what m is. We know that m is 7, but we still don't know what c is. But we do know a situation where we know x and y for a coordinate. In fact, we know 2 of them. So what we're going to do is substitute in those values of x and y to find out what c is. So y at the first coordinate is 111 equals 7 times x, which was 15 for that first coordinate, and then plus c. So we're going to get our solving lines in. And the first thing we're going to do is work out what 7 times 15 is. So 7 times 15 is 105. And we're going to subtract that from both sides. So take away that 105 from both sides. And that leaves us with 6. So c is 6. So we're going to rewrite the same equation again. But we know that the gradient is 7. And we know the y-intercept is 6. So we can actually just write that in as our answer. 7x plus 6. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5-meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. Any number to the power of 0 is equal to 1. So it doesn't matter if it's a number or a letter, it's always going to equal to 1. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So we're going to first of all look at the starting section. So we've got the probability of a blue being picked from bag 1 is 7 over 11. So the probability for blue and red must equal 1. So what do we add to 7 to get to 11? Well, we add 4, and so it would be 4 over 11. So these two here must add up to 11 over 11, which is 1. Looking at the next section, we've got 11 over 15 chance of picking a blue. So what's the probability of picking a red? Again, 11 over 15 plus the probability of a red must equal 1. So that's going to be 4 over 15. 4 over 15 plus 11 over 15 is 1. And we've got the final section down here. Now, this final section, we haven't got any fractions for, but bag 2 is independent to bag 1. So bag 2 is just sitting there ready to be picked after we pick bag 1. So the probability is going to be exactly the same as the ones at the top. So we've got to first of all realise that these triangles are similar, so we can work up what the scale factor is. We need two corresponding sides, which I'm just going to pick these top ones, and we're going to work out the scale factor from those. Now the scale factor is how to get from the smaller to the bigger. So what I'm going to do is I'm going to do 91 divided by 13, which is 7. So we know we times 7 to get from the small to the big. Now here we've got a problem because we're actually going from the big to the small. And when we go the opposite way around, so instead of times 7, we're going to divide by 7. So on our calculator we do 126 divided by 7, and we get the answer 18. We're going to start off by just writing the decimal in the standard form, which is 4.3. And we're going to look at the power. Now, if the power is positive, it means the standard form number is a really big number. If it's negative, it means it's a very small number. And here it's negative, so we know it's a small number. Now we're going to do the amount of jumps that it shows in the powers. So it says a 5 there, so we're going to do 5 jumps. And because it's a small number, we're going to go to the left to make it a small number. So we're going to go 1, 2, 3, 4, 5 jumps. So the new decimal point is going to be here. All the jumps that we made, we're going to fill in with zeros. And because it's decimal, we're going to start it off with a 0. So our new number is, or our ordinary number is 0.00043. Now it's important to realise that we shouldn't really think about it as jumping the decimal point. We're actually shifting the number, but it's all relative and it's a lot quicker just to move that decimal point. To be able to work out this question, we need to work out the amount of student hours required to paint the wall. And to work that out, we've got 6 students and it takes them 11 hours. So 6 times 11 means it's going to take 66 student hours. So if we had 1 student, it would take 66 hours. 2 students would be half of that because they share the work, and etc, etc. So here we've got 6 students and it take 11 hours. And it says how long will it take 7 students? Well, if there's 66 hours, or student hours, but they're sharing the time, we just divide 66 by 7. So 66 divided by 7 is 9.428, blah, blah, blah. And it says it wants its 2 decimal places, so it will take them 9.43 hours. Now check this makes sense. We've got 6 students and it takes them 11 hours. So we'd think if we had more students helping to paint the wall, it would take less hours. So we've gone from 11 hours to about 9.5. So that sounds right. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times 2 powers of the same base and they're both v, then we just add the powers together, so that'd be 8, and we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power 4. Now we know when we multiply 2 powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power 4 times y to the power 4, we just add them together, so it's y to the power of 8. To find an error interval, what we need to do is find the smallest and largest that a number can be. So I start by just drawing a quick number line, and we put our number in the middle, which is 89.6. Now we're looking to the nearest tenth, so what I'm going to do is I'm going to write down the next number down and the next number up in tenths. So the next number down would be 89.6.
89.5. The next number up would be 89.7. Now the bounds, the upper and lower bound, the maximum and minimum number it could be before rounding, are going to be at the halfway points. So here and here. And so all we need to do is work out what those numbers are. So halfway between 89.5 and 89.6 is 89.55. And halfway between 89.6 and 89.7 is 89.65. So those are going to be our lower and upper bounds. But how do we show it as an error interval? Well, we put t in the middle because it tells us that t is representing the time. And we show it with inequalities. Now, the number can be 89.55, but it can't be 89.65 because that would round to 89.7. So we say everything that's less than but not equal to.
With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. There are two outcomes that will end up with the athlete hitting one hurdle, and that will be jump hit here and hit jump here. If they jump both hurdles, obviously, or if they hit both hurdles, that's not them hitting one hurdle. So to work out the probability of ending up with jump and then hit, what we're going to do is we're just going to multiply those two probabilities together. So 4 over 7 times 1 over 10, which would be what, 40 over 70. And do the same with hit jump. So hit and jump will be 3 over 7 times 10 over 13. So 3 over 7 times 10 over 13, which will be 30 over 91. Now here's the problem. We've got two fractions. We've got two probabilities. We've got the probability it will jump and hit, and the probability it will hit and jump, or the athlete will. And we're looking at the probability of this one or this one. And the word or in probability means add. So we're going to do 4 over 70 plus 30 over 91. And using the calculator, that gives us 176 over 455. Whenever we're asked to compare two box plots or two cumulative frequency graphs or a cumulative frequency graph and a box plot, you're always going to be comparing two things. You're going to be comparing the median and the interquartile range. Now if we do a little table, like a good table, and we've got male and female, and we're going to work out the median, which is the first thing we have to compare, and the interquartile range. And it can actually just be the normal range. We don't need to pick the interquartile range. So the median for male is this line here, this bit here. And if you look down, that is 22. And for females, it's this one here. If you look down, that's 18. And we just go write a sentence. So you say something like the median is higher for males, brackets 22, always show your values, than for females, brackets 18. Okay, easy. Next we're going to do interquartile range. Interquartile range is slightly harder because you need to do the distance between the upper quartile, which is this line here, and the lower quartile, which is this line here. And so that would be 24 take away 19, which would be 5. And for the females, it would be 28, which is this one here, take away 16, which is this one here, and that will give you the answer of 12. So the next sentence we say is the interquartile range. They don't mind you writing IQR, that's absolutely fine. Is, now you can say lower for males or higher for females. I'm going to say lower for males, brackets 5, than for females, bracket 12. Now, the median is basically on average the males are higher. Okay, so it's just an average, says on average they're higher. The interquartile range is an interesting one. Anything to do with range is about consistency. So it's actually quite good in many instances to have a lower interquartile range because it just shows you're more consistent. So you say the sentence could be that the males are more consistent because the interquartile range is lower. Generally speaking, the higher the median, the better. The lower the interquartile range, the better. Apart from if you're talking about things that like the time it took you for a race, you kind of want the median to be lower. Still, you want the interquartile range to be lower because you want to be consistent. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3. And so it would be 3 brackets k plus 1 over 45. And the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together. And I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4. And then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. This question relies on the fact that you know what the equation of a circle is. And the equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So we're told that y is proportional to x squared. And the first thing I'm going to do is replace that proportionality sign with an equals. And to do that, I've got to times the right hand side by k. So we get y equals kx squared. Then I'm going to replace the x and the y for the values given to find out what k is. So y is 75 when x is 5. So we know that 5 squared is 25. And then just quickly solve this. So I'm going to divide both sides by 25, and as you can quickly see, should be 25. As you can quickly see, k is going to equal 3. Rewrite the equation. So I'm just going to rewrite this, but with k as 3. K is a constant, so we know that that will be correct for all values of y and x. Then it says find the value of x when y is 12. So I'm going to replace the y for 12 and then just simply solve. So I'm going to start by dividing both sides by 3. Then I'm going to square root both sides. So we've got the value of x equals 2. We're asked to solve this quadratic, and we're told that we're going to put the answers to 2 decimal places. So we're going to be using the quadratic formula. For the quadratic formula, we need to work out what a, b, and c are. A is the coefficient of the x squared. Now, it doesn't look like it has a number before it, but it does. There is a 1 there. So a is 1. B is the coefficient of the x, which is 5. And c is the number left on its own at the end, which would be minus 20. So we're going to write out the quadratic formula. And we're going to substitute in the value. So it's minus b, And I always put the values I substitute in brackets on the calculator, because if they're negative, we can get into problems. B squared minus 4 times A times C over 2A. And if you type that into the calculator with a plus there, so change that for a plus, you're going to get the answer of 2.623 blah blah blah. If you go back on the calculator, use the cursor keys to change that to a minus, you get the answer of minus 7.623 blah blah blah. Rounded to 2 decimal places, that's going to be 2.62 and minus 7.62. Okay, so first thing I'm going to do is just a quick sketch of this diagram. And so we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into 2. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half a plus b times the height, and the 2 parallel sides are on the left and the right, so it's going to be half times this part here, which is 40, plus this point here, which is 160, and then the height is actually the width, so the height is this bit here, so it's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide, and again 160 tall. So 3 times 160, which would be 480. And so we need to work out the total area. And we do that just by adding the 2 together. So 200 plus 480, which will be 680. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3, because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line, but if you look, it crosses the y-axis at -1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region which is here, and we can pick a point in the region. I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2, so it's y is greater than 2. We have a look, the fact that our line is dashed, it's not going to be equal to 2, because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than -3? Well, yes, it is. So it's going to be x is greater than -3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals because what we need to do is work out what inequality it's going to be. 0 take away 1 is -0. So what is 4 compared to -1? Well, 4 is definitely greater than -1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it because it can equal it as well. I'm going to start by labeling this triangle, and so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. To solve when we've got two equations that aren't linear, and here we've got a linear and a circle equation, what we're going to do is we're going to solve by substitution. We're going to substitute one into the other. So here we're told that y is equal to 3x plus 11, and we actually have a y in our second equation. So what we're going to do is just substitute it in. So we've got x squared plus, and instead of y, I'm going to say what the first equation is. I'm just going to replace it for what y equals in the first equation, which is 3x plus 11. And it's y squared, so it's that squared, equals 125. Okay. Now we need to expand the brackets there. And so we're going to have x squared, and you can use any method you want. And don't forget, when you square brackets, that's just going to be 3x plus 11 brackets 3x plus 11. So we're going to do 3x squared, which is 9x. So how are we going to write this? So plus 9x squared. And then we've got 3x times 11 plus 3x times 11, which is 33x plus 33x, which is 66x. And then we've got 11 times 11, which is 121. Now at this point we want everything to equal 0 because it is a quadratic. So to solve it we need it to equal 0. So we're just going to tidy it up and add the bits that need to be added, and we're also going to subtract 125 both sides to get it equal to 0. So x squared plus 9x squared is going to be 10x squared. So we might as well just write it as 10x squared. We've got 66x just on its own, and we've got 121, take away 125, which is minus 4, equal to 0. Now it says it wants our answers to two decimal places, so chances are these won't factorise nicely, so we're going to be using the quadratic formula. And so we need to find out what a, b and c are. So a is the number before the x squared, the coefficient of the x squared, which is 10. B is the coefficient of the x, which is 66, and c is the number on its own at the end, which is minus 4. The quadratic formula will be minus b, and I always put the values we substitute into brackets, because if they're negative that really helps us, plus minus square root of b squared minus 4 times a times c, all of that over 2 times a. When you put that as a plus, then into the calculator we get x equals 0.060 blah blah blah, and when you put a minus there we get the answer of minus 6.660 blah blah blah. Now you might think, well, how are we going to find out what the y's are? Well, if x is 0.06 blah blah blah, we've got an equation here that says to find out what y is, we times the x by 3 and we add 11. So we're going to times that first solution by 3, then add 11, and that gives us that y is 11.180 blah blah blah. We're going to do that with the next solution, and we're going to times it by 3 and add 11, and when we do that we get minus 8.980 blah blah blah. We're going to round each of these to two decimal places, so we've got 0.06 and 11.18, and the second set of solutions is minus 6.66 and y equals minus 8.98. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.